Hello and welcome to MLOps Minutes. So in this episode, which is a continuation of the previous episode and also a summary of the key points from all the other episodes, I'm going to show you how and even what the methods are to implement a step such as data splitting very quickly, very cleanly, and to make it industrializable from the very first iterations. Here we go. If you remember in the previous episode when we came out with our data splitting brick, we expected to have two big bricks. One brick where we'll have integration PDFs and associated images, which we'll extract on one side. And in another brick, we'll take documents that have nothing to do with each other. And we'll have three directories: train, validation, and test to train our AI. On Azure ML, it's going to look like this, i.e., we'll have our data set where we'll have our list of flat PDFs, our extraction phase, which will extract our flat images, which can then be consumed as input to this data split step. This stage will also consume the PDFs to output the integration PDFs. And will also consume another data source, the labels which come from our previous data annotation step. As output will our images for training our AI, our train, test, and validation directories, and another directory where we'll have our integration test PDF part. This will be the output of our data splitting stage. To implement this step, you might be tempted to use a Jupyter notebook. But the thing is, for this type of requirement, you know exactly what you're expecting as output. What's more, if you do everything in a Jupyter notebook, you run the risk of making bugs and mistakes, and you'll realize that in the next steps, when you go to work on the training part, you could potentially come back to your Jupyter notebook. You could potentially come back to your Jupyter notebook after maybe a weekend or a vacation, but you might not be able to regenerate your steps because you no longer know the order in which you played your Jupyter notebook cells. A tip for this type of need: when you've got some code and you know exactly what you want, get out of Jupyter Notebook and move on to the next time-saving step, i.e., go to the IDE, use a PyCharm type editor, and immediately set up TDD, i.e., test-driven development, which will enable you to iterate very quickly, and you can use the debugger and keyboard shortcuts. In terms of code, we look at the solution. For the moment, you'll have a train directory only. And in this train directory, you'll find a pproject2ml with poetry, here representing a project. And in this project, which is the launcher of the Azure ML experience, you'll find our 3 steps: extraction, label, data split, and output. And each little box here is a sub-project, i.e., in the extraction step, you'll also find a pproject.toml. So it's a completely independent project, and it's the same for our data split step here with a pproject.toml. So to work in it, what do? I open my code directly in the data split step. So I isolate myself in this project. In other words, instead of seeing the whole project, I isolate myself in this little box that's not coupled to the others, because there's no coupled code, and I can work in it with peace of mind. So to get started, you'll need your inputs. You can create a set of test inputs here with images. and labels. Here you have images, and here labels. These correspond to the output files of our annotation application, from which we've removed all information not relevant to our test, and we'll find a set of associated PDFs. So the idea is to have as little data as possible to be able to create a test set. This allowed me to set up this brick to start working. So this is the final result, but it's important to know that to start with, I just set up a test, the minimum possible, and wrote very quickly, debugging everything I needed. I wrote very quickly, debugging everything I needed to implement it. So for example, if I actually type Alt F5, a shortcut, I'll be able to enter the debug mode, and then I'll be able to see and inspect the data in my code. What could I look at here? For example, the data in the files that have been played. And we can review my test. We'll find the structure. I'll get out of the debug. We will find an integration directory with a PDF containing an image. And then you'll find my image output directory with my 3 directories, train, test, and evaluate. When I started at the beginning, my test was not unitary. My code was not clean. I was able to iterate very quickly. Then once I had my first set of working code, to clean up my code, do some dependency injection, and make my test unitary. By working this way, I was able to go extremely fast. In addition to that, I'm going to give you a quick summary of the key points to be reproducible. In other words, to be reproducible, you have to be able to version the data. So versioning the data, here I haven't told you much about it, but your data here has to be versioned somewhere, in a data lake, for example, or some other data source. But it really needs to be versioned. We'll come back to this in future episodes. Your code today is versioned in Git, which is great. We're using Poetry, a tool that allows us to freeze dependencies at a given point in time. In other words, we'll have this Poetry lock file, which takes the dependencies of the dependencies of the dependencies, and also saves the hash linked to the dependencies. This guarantees that when we replay an experiment at a later time, we can be sure of having exactly the same version of the libraries as when we played it. We also use Docker, which means that for each experiment here, we'll use a Docker file where we freeze the version of Python and also freeze the version of the OS we're using. In other words, it's always the same, so we can be sure that we'll be able to reproduce it. In our Docker file, we'll use Poetry to retrieve our dependencies. And lastly, with regard to reproducibility, we're going to use the seed function, which, given by Python's random module. In other words, at code level, we'll be able to freeze a seed, which guarantees that the random function will always return different results. But when we freeze a seed and don't change it, if we replay the same piece of code, the random will no longer be random and will always return the same result. So when we're in the exploratory phase, we can change the seed, but once we want to freeze a version, we don't move it anymore, and we know we're reproducible. That's it for this episode. It's a summary of the key points required to set up each little box in our project. And what you have to understand is that for the extraction phase, I proceeded like this. For this brick, I proceeded like this. And for all the bricks, I proceeded like this, which enabled me at the time I did the project, I had to give courses in less than 2 weeks. I practically did the project in less than 2 weeks. And each brick is extremely quick to make. When you isolate yourself on it, you're not coupled, and it simply goes very, very fast. And we're de facto industrializable, i.e., we're ready to go into production. The last little point I forgot to mention is that every little box, if I come back to each little box here, these little boxes are not at all coupled to Azure ML, i.e., the code is independent of Azure ML, apart from the launcher, which means that if tomorrow you don't want to work in Azure ML, but in Databricks, for example, or another provider that works with MLflow, you're already compatible and can change provider and protect yourself from the infrastructure you're using. Thank you very much, and see you soon for more videos.